Hello, my name is Sandra Espinosa, and my project is about interfacing Sharp GP2Y1014AU0F Sensor with Arduino to build Air Quality Analyser. So first we will see all the parts and the connections. The main part is the Arduino Nano. The other parts are connected to this. The other main part is the Sharp GP2Y1014AU0F sensor that is a tiny 6-pin analog output optical air quality optical dust sensor that is designed to sense dust particles in the air. We can see all the connections to the sensor. It works on the principle of laser scattering. When air-containing dust particles enter in the sensor chamber and the dust particles scatter the IR LED light towards the photo detector. We have the two resistors connected to the DCC, and all sensors and the OLED is connected to 3.3 voltages. The sensor have 6 pins. The first one is the VCC pin and is connected to the 5 voltages through the 150 ohms resistors. The second one is the LED ground pin connect to ground. The sixth one is the positive supply pin connected to the 5 voltages of Arduino. It's a simple VCC, the first one and the last one. The resistor supply the sensor and the capacitor. We have two ground connections, that is the pin number 2 and the pin number 4. The pin number 2 is connected to ground and the pin number 4 is connected to the ground of Arduino. The pin number 5 is the sensor analog output pin and is connected to any analog pin to Arduino. We can see in color green. The pin number 3 is the use to toggle LED on off and is connected to any digital pin of Arduino. We can see in color blue. The circuit is very simple as we are only connected the GP2Y10 sensor and the OLED display module with Arduino Nano. The sensor and the display are powered with 5 voltages positive and ground. The BO pin is connected with A5 pin of Arduino Nano. Now you can see the codification for this simulation. I need some libraries files for Arduino to make this codification. You can see the libraries that I include. I define the OLED width and height. I define the SPI communication pins where OLED display is connected. I created an add the fruit displayed instance with the width and the height defined earlier with the SPI communication protocol. We have the temperature sensor and other definitions for the sensor that we need. This function is for the pressure. This is for the amount of CO2. This is for the temperature of the CCS. For the dust sensor, I use the code for the measure for the lead, the outbeats, and the dust density. With these codes, I maintain the output of the dust sensor is connected to the A3. The IR pin inside the dust sensor is connected to D2. The AD converter raw output and the dust density based on the formula. The float I'm used for the temperature, humidity, and pressure sensor. Then for the delay time, for the serial port. In the part of the setup function, initialize the serial monitor at the baud rate of 9600 for debugging purpose. We need for the dust and VOC sensor. For the CCS section, we need to calculate the temperature and set the offset using the BME280. We use a temperature of 25. The delay time is 1000. In part of the OLED, we put the added fruit. We need the pin mode to control the dust sensor LED. That's all the functions that I introduced to make the simulation. Once the hardware and code are ready, it's time to make the testing and have results. Useful information has been simulated for the results. I obtained some data for the sensor with the app of the simulation. Now I introduce some data and look for the results. In the panel, we have the pressure and humidity, air quality, the temperature, and we can see the graphics of the results. Now you can see the results of this project. Thank you so much.